Hi, everybody. Today we want to work on a lesson on how to complete conversions using a method called dimensional analysis. Now, maybe in another class you've used this method and you've called it the factor label method. That's because we're going to be setting up factors and using labels on the top and bottom of that factor, and then filling numbers in on the top and bottom of that factor. Whoops, I did not mean to do that. Filling numbers in on the top and bottom of that factor to make the top and bottom of that factor equal. And then we're going to cancel out the labels, do some math with the numbers, and we will have converted our number. For example, one of the problems today, we're going to figure out how many centimeters long a football field is. Okay, so let's get working on it. By the end of this lesson, you're going to be able to do 1 or 2 units conversions using this factor label method. Let's do a real quick example. Like, how many seconds old will you be on your next birthday? Now, a lot of my students are 16 years old, okay, on their next birthday. I have a lot of students turn 16. So we want to set up a label where we can divide out the year label. Now, I don't know how many seconds are in a year, but I know how many days are in a year. I know it's 365, and I'm going to put the 0.25 because of the leap years, days in a year. Do you see how what I filled in there, the top and the bottom of my factor are equal, and the years will divide out when I divide by years and multiply by days. Now, I can keep going. I'm going to switch to a different blue because it's a little hard to see that one. But I can convert from days to hours. We know there's 24 hours in a day. Days divide out when we multiply by 24 and divide by 1. We keep going. We know that there are 60 minutes in an hour. Top and bottom of my factor are equal. Hours will divide out. We know there are 60 seconds in a minute. Top and bottom of my factor are equal. Minutes will divide out. And to figure out how many seconds old you would be on your next birthday, you would put your number in here. But if you happen to be turning 16 on your next birthday and you complete this, do you think you're a billion seconds? A trillion? How old do you think you are? Take 16, multiply by 365.25. Multiply that by 24, multiply by 60, multiply by 60, and you should get this number. On your 16th birthday, you are 504,921,600 seconds old. So not quite to a billion, but over halfway there. Now, these are some conversions that you're going to need to know for science. Some of these you've learned in metric. The others, like this, I would give these to you. And if there's any others that aren't like common knowledge, for example, like I expect you to know that an hour has 60 minutes. I'd expect you to know that a foot has 12 inches. But the ones here that I put the little check mark behind, they're not always common knowledge. So I would give those to you at the top of a quiz or a test or a worksheet. But to do homework, or if I don't put them at the top of a worksheet, I would think that you should write them in your notebook so that you have them handy for doing conversions. So you might want to pause and put these numbers in your notebook. We're going to use those numbers to do some conversions today. For example, let's say that a recipe for cupcakes includes 2 1/4 cups of water. But we're at school and the only thing we have to measure water is a graduated cylinder. So we need to know how many milliliters to measure. You always start with the given number. And then you set up a factor and you put in your labels. We got to put cups on the bottom to try to get rid of it, right? Always put that label on the bottom and the label that you want on the top. And then you have to use the equalities from the previous slide. We know there are 240 milliliters in every cup. Now you divide by the numbers that are on the bottom, you multiply by what's on the top, so the cups will divide out. 2.25 divided by 1 times 240, and you will get 540 milliliters. If the only thing we had to measure was a graduated cylinder, we would still be able to accurately measure that water and make our cupcakes. Go ahead and try this one. Pause this slide. Start with the 75 kilometers and set up a factor, convert from kilometers to miles, and use the numbers that I gave you on the previous slide. Pause this so you can try it. And then you should get 46.5 miles for your answer. If you don't get that for an answer, you can check with your teacher and see what you did incorrectly, because you do need to know how to do one-step conversions. Now, this is an example of something that might take 2 steps. It's still one label, like 0.89 meters. But we need to figure out how many inches this height corresponds to, so that we know how tall this child is in the imperial system or the English system. And this is going to take more than one conversion, because I don't know how many inches are in a meter, but I do know that, if I go from meters to centimeters, I learned in my metric lesson that a centimeter is 1/100th of a meter. And then I also know, because it was given on that other slide, that there are 2.54 centimeters in an inch. Now, this problem shows us some special things that we need to remember. First of all, set up your labels so that it divides out. Like if centimeters is on the top on this factor, it goes on the bottom in this one, so that it'll divide out. And the only label that didn't divide out here is inches. But the other thing, on some of the other problems, like you took the 2.25 times 240, when your numbers are on the bottom, you divide by them. So we want to take 0.89, divide by 0.01, and divide by 2.54. And you're going to end up with 35 inches. So this child is just under 3 feet. Here's another one that will take 2 or 3 steps. The football field is 100 yards long. What's its length in centimeters? Now you could go from yards to feet, feet to inches, and then inches to centimeters. Occasionally, I have students who do it in less steps. They'll go from yards to inches because they know how many inches are in a yard, and then go from inches to centimeters. Either way is fine. Pick a way, start with 100 yards, and set up your factors. Now pause this and try it, because in a minute I'm going to give you the answer. Now hopefully you solved this, and when you unpause, you will get this number to match the answer that you got by solving your problem. What do you do if there's two labels? You can see in this problem there's two labels, miles and hour. Well, when you do this, one thing I want to suggest is that, oops, let me get rid of this a second. One thing I want to suggest is that you write your labels like this. I'll even have some students who like to write the 1 under there because it's really 55 miles for every 1 hour of travel. So 55 miles per hour. And we have to change both labels because we got to change the miles to meters and we got to change the hours to seconds. What you want to do is you pick one label and work on that one first. For example, I can convert my miles to kilometers and then my kilometers to meters. If you look back on the conversion numbers that were given, we know that a kilometer is 0.62 miles. In metric, we learned that a kilometer is 10 to the third or 1,000 meters. So this is going to be sufficient to change the one label. The miles and the kilometers will have been converted into meters. At this point, if I stopped, I would have an answer in meters per hour. But we want our answer in meters per second. So we're going to set up a couple more steps in our problem, to change our hours into minutes. Now, do you see how I put the hours on the top? Because if it's on the bottom here, I have to put it on the top over here to get rid of it. Now, I still need to put in numbers to make the top and bottom equal. 1 hour is equal to 60 minutes. And then I'm going to do the same thing. To go from minutes to seconds, the minutes has to be on the top, so it'll divide out. I'm still going to put in numbers. 1 minute is 60 seconds. So when I solve this problem, I'm going to take 55. Let me get a little highlighter here. What color am I in? I don't know if we'll be able to see that. I'm going to start with 55. I'm going to divide by 0.62. I'm going to multiply by 1,000. I'm going to divide by 60. I'm going to divide by 60 again. And then I'm going to hit my answer, my equal sign. And you should get 24.6. And let's look at the label. Look what's left. Meters and seconds did not cancel out with anything. I have gotten my answer in meters per second. One more problem, and then we'll let you to practicing this and some exercises and assessments and things. But this particular problem says that a runner covers 100 meters in the dash in 14.2 seconds. Okay, not a world record time, but how fast are they running in miles per hour? So we need to know, and this is probably from general science and other math classes that you've had, that speed is distance over time. So we're going to take the 100 meters, which is the distance, and divide by the 14 point, I missed the 2, seconds. 100 divided by the 14.2, we got 7 meters per second. It's like 7.8 or something. Now that 7 meters per second, you can take and start setting up several factors to convert your meters into kilometers and then miles, and to convert your seconds into minutes and hours. So pause the video and try that on your paper. Now, hopefully you've tried that on your paper. I am going to do this one with you because this is one that's usually a little more challenging. I'm going to pick one label at a time. First, I'm going to work on the meters. We know there's 10 to the third meters in a kilometer. I don't want my distance in kilometers though. I want it in hours, or excuse me, I want it in miles. So I go back to those numbers that, I'd give you on a quiz or a test. Each kilometer is equal to 0.62 miles. So top and bottom of my factor are equal, and the kilometers, they're going to divide out. Now this is miles per second, but I want miles per hour. So I got to convert my seconds to minutes. We know that a minute is 60 seconds. Seconds has to be on top in my factor because it's on the bottom over here, and it'll divide out. I got to put the minutes on top here. 60 minutes in an hour, top and bottom are equal, so that my minutes divide out. And when I'm done, miles an hour, they were not canceled. So my answer is in miles per hour. I got 15.6, or maybe you rounded it to 16. That's fine. You should be able to use numbers that are equal and set up factors to change 1 or even 2 units for any number and convert it into a new unit, a new label, but an equal quantity. Like 7 meters per second and 15.6 miles per hour, those are the same speed. They are just expressed in a different unit. Okay? So good luck. I'm sure that using those conversions, you're going to